Good afternoon. Let us start with today's session. So let us move further and see what are the various terminologies which are used in the queuing theory. Okay, there are before that there is assumptions. As we have seen the assumptions in assignment also, assumption is game theory also. We have some assumptions in queuing theory also. So the first assumption is the queue follows FIFO discipline. So what do you mean by this term FIFO? I have already explained you yesterday. FIFO means first in, first out. So those who will be there in the line first, they will be served first. Okay, so we will have an assumption that it will be a FIFO discipline. Those who will come first will be served first. Second is arrivals follow a Poisson distribution with a rate of arrival lambda per hour. Most important thing in terms of units. 10-10 मार्क के सम आते क्यूइंग थियरी पे, बट अगर यहाँ गड़बड़ कर दिए इन यूनिट्स, the entire sum will go wrong. You will get 0 marks. The third assumption is again an important one. The service follow. The service provider क्या follow कर रहा है? Service provider is following exponential distribution. So these two are important things. Arrivals are following Poisson distribution with a rate of arrival lambda per hour, and service provider is giving the service at a rate of service as mu per hour. Again, these units are important. Mu per hour. We always need how many customers will be served per hour. In simple form, if I tell, we will be requiring how many customers are served per hour, and in arrivals we want to find out how many customers arrive per hour in simple terms. Okay. Then the fourth assumption is infinite population method is considered. So we will not restrict a queue length to any of the population. It will be anyone can come and be in the line. And the fifth one will be infinite queue model is considered. That means the length of the queue can be infinite. So these are the assumptions we will be making to solve our problems of queuing theory, unless and until specified in the question. अगर क्वेश्चन में स्पेसिफाई कर दिया है कि you have to take finite population, then it is a different case. But if it is not mentioned, in general, we will be taking these assumptions. Okay, so let us move further. So notations in queuing theory, as I already told, arrival rate notation is given by lambda. So we have seen in the previous slide, it was lambda per hour. So it's just a notation that arrival will be denoted by lambda. Similarly, we have service rate. Service rate will be denoted by mu. These are the standard notations. Then utilization factor. What does this mean? Utilization factor means, okay, let me explain to you with an example. What do you mean by utilization factor? Now let us say in a morning time, most of you come to the college and you are willing to leave the first lecture. मुझे चलो अपन थोड़ा सा काम कर लेंगे, थोड़ा कैंटीन में बैठेंगे, फर्स्ट लेक्चर गया, ठीक है, कोई बात नहीं. Okay, so in that particular hour, there will be more line in the admin counter. So what will be there? Continuously, admin counter will be providing the service. So during that hour, they are fully occupied. But जैसे जैसे दिन बढ़ेगा, आगे क्या होगा? आप कोई लेक्चर में चले गया, कोई कहाँ चले गया, let us say break time, तो वो टाइम पे एडमिन बंद है. So that means this service cannot be utilized. So you have to find out from the entire day shift how many time they are working, how many time they are not working, or they are sitting idle. So that is nothing but the utilization factor or traffic intensity. So utilization or factor or traffic intensity means how many times the system is working. Okay, or at how many times the system is working, that is nothing but the utilization factor. Then we have again, what is the length of queue? Okay, so what will be length of queue? How many persons are there? Okay, let me tell you, or let me avoid the misconceptions here, that this all answers we will get will be on average base. Okay, so for the entire day, for the entire 10 years, let us say this is the data, and this is the average length of queue at any time. आप बोलोगे सर यहाँ पर आंसर 5 आ रहा था, बट मैं वहां जाके देखा वहां तो 7 लोग की लाइन लगी थी. So that is not the length of queue at that particular time. It is the average length of queue for the entire service period. कभी ज्यादा भी हो सकती है, कभी कम भी हो सकती है. So whatever answer we will get, that will be average length of the queue. Then length of system. So there are two different things now. Again, length of queue and length of system. So can anyone tell me what can be the difference between them? Length of queue and length of system.
Queue might not consider servers.
Queue might not consider server, और थोड़ा सा गड़बड़ कर दी, थोड़ा सा गड़बड़ है. लॉजिकली सही जा रहे हो, बट थोड़ा सा बोलने में गड़बड़ कर दी।
क्यू में सर्वर नहीं इंक्लूड होता होगा और सिस्टम में सर्वर को इंक्लूड करके काउंट करते होंगे।
सर्वर नहीं बोलोगे, कुछ और वर्ड यूज, सर्वर मतलब हु इज
सर्विस
गिविंग द
प्रोवाइडर और
सर्विस।
जो भी है सर।
नहीं, तो फिर गड़बड़ हो रहा है, फिर तुम गलत बोल रहे हो। ओके, लेट मी एक्सप्लेन यू। Length of the queue means how many persons are there in the queue, and length of the system means the number of persons in the queue plus the number of persons who are getting service. So it is not the service provider, he is the person who are getting the service. So that means the total number, if I tell the length of the system in another way, it will be total number of person in the system. That may be that is the addition of the persons in the queue plus the number of persons who are getting the service. So length of queue means only those who are standing in the queue waiting for their turn, and length of the system means those who are waiting plus those who are getting the service at the same time. So that is nothing but the difference between length of the queue and length of the system. Then similarly, we have waiting time in queue. It's very simple. How much time you have to wait in the queue for your turn to come. So again, there is a difference. Waiting time in queue. So how much time you have to wait in the queue? Line में कितना time लगना पड़ेगा? And the next one is waiting time in the system. Okay. तो क्यू तो हो गया. Let us say you have कोई बहुत से लोग, आप लोग पासपोर्ट वगैरह बनाने भी गए होंगे. So आपको पहले तो लाइन में लगना पड़ेगा आपका नंबर आने के लिए. So that will be waiting time in the queue. उसके बाद क्या होगा, आप वो काउंटर पे जाओगे, फिर वो डॉक्यूमेंट्स वेरीफाई करेगा, किसी का कुछ नाम में गड़बड़ है, किसी का क्या है, आधार कार्ड, ये वो बहुत कुछ वेरीफाई करेगा. सो इट डिपेंड्स ऑन पर्सन टू पर्सन. किसी का डॉक्यूमेंट्स एकदम क्लियर है तो उसको 2 मिनट लगा होगा, किसी के डॉक्यूमेंटेशन में कुछ मिसिंग है तो वो बोलेगा हाँ ये मिसिंग है, ये निकाल के दो, उसमें 1 मिनट और जाएगा. सो द टोटल टाइम इन द सिस्टम, दैट इज वेटिंग टाइम इन द क्यू प्लस द टाइम गेटिंग द सर्विस. इफ आई टोटल ऑल द टाइम, दैट विल बी द वेटिंग टाइम ऑफ द सिस्टम. So waiting time of the queue means how much time you are waiting in the queue for your turn to come, and waiting time in the system means the total time with getting the service. That means time from which you started in the system and the time which you left the system after getting the service. That is waiting time in the system. The next is probability that there are n customers in the system at any point of time. So let us say you will ask me, sir, आज मैं 11 बजे जाऊंगा फीस काउंटर पे, तो कितने लोग होंगे वहां पर, एक अंदाजा तो बताओ. सो दैट इज नथिंग बट द प्रोबेबिलिटी. सो विद द फॉर्मूला वी कैन ऑल्सो फाइंड आउट. सो दिस इज ऑल प्रैक्टिकल एप्लीकेशंस. सो लेट अस से देयर आर n कस्टमर्स. तो मैं अगर बोलूंगा सर आज मैं वहां 11 बजे जाऊंगा, तो 10 लोग रहेंगे, उसके चांसेस क्या है, या 3 लोग रहेंगे, उसके चांसेस क्या है. मैं 3 लोग की लाइन लगा दूंगा, मेरे को 100 लोग की लाइन नहीं लगाना. सो दैट यू कैन फाइंड आउट फ्रॉम हियर that how much at that time, how many customers will be there in that queue, or what is the chances that many customers are there in the queue. उसके बाद है number of parallel service channels. So as we have seen the example in a bank, or not say in the bank, how many number of service parallel channel means how many counters are open for the same service. Okay, so that is known as a number of parallel service channels. So this is mostly coming into the picture when you are using multiple server models, that how many counters should be open or how many counters are there. So any doubts now in the notations?
No, sir. No, sir.
So let us go further. Formulas for single channel queuing theory or single server queuing model. So this I have already posted to you in the WhatsApp group. So just I will go fast in this. It's just a formula which you have to remember. Okay, so it is utilization factor of traffic intensity. So the formula will be lambda by mu. Just observe these terms, lambda by mu. So if you want to calculate utilization factor, you will need the value of lambda and you will need the value of mu. What is lambda? Lambda is the arrival rate, mu is the service rate. Okay. Okay, so let me ask you a general question. If utilization factor is lambda by mu, what would be the idle time, or what will be the idle time for the system? अगर यूटिलाइजेशन फैक्टर इतना है तो आइडल टाइम कितना होगा? इट्स अ जनरल लॉजिकल क्वेश्चन. यूटिलाइजेशन फैक्टर क्या होता है? हाउ मच टाइम द सिस्टम इज बिजी. यस. सो हाउ मच टाइम द सिस्टम विल बी आइडल. सिंपल क्या हो जाएगा? परफेक्ट आंसर विल बी 1 माइनस लैम्बडा बाय म्यू. देखो अगर सिंपल अगर मैं करता हूं कि इफ आई टेक द प्रोबेबिलिटी ऑफ एंटायर थिंग बिजी इज 1, ओके, तो आइडल टाइम तो 0 हो जाएगा. But now I am telling you that utilization factor is 80%. Sometime they are free. तो अगर 80% यूटिलाइज है तो फ्री कितना रहेगा 20%, दैट इज 1 minus 0.8, दैट विल बी 0.2, दैट इज 20%. So just you have to subtract 1 minus lambda by mu or 1 minus that rho, you will get the answer for idle time. Then we have waiting time in the system. How much time you have to wait in the system? Again, students make the mistake here, they don't read the question properly. Here it is waiting time in the system. System means the entire thing, not only in the queue waiting for the service. It is waiting in the queue plus getting the service. So the formula is Ws is equal to 1 divided by mu minus lambda. So again you can see the inputs are mu and lambda. Okay. Third, waiting time in the queue. Now it is just how much time you have to wait in the queue for your turn to come. So it will be denoted by WQ, and you can see it is Ws multiplied by again lambda by mu. Then it can also be written like this, 1 upon mu minus lambda, because Ws is 1 upon mu minus lambda into lambda by mu. So I just substituted the value of Ws from above equation. Then next is length of the system. How many number of persons will be there in the system at that particular time in average time? So it will be lambda upon mu minus lambda. So again you can see the inputs are lambda, mu and lambda. Okay. Next, length of the queue. LQ is simple, as we have found out. WQ, it is LS multiplied by lambda by mu. So if I put the value of LS here, I will get one more formula, that is lambda upon mu minus lambda into lambda upon mu. Then probability that system is idle. अच्छा, किसी ने जो बोला यहाँ से देख के बोला रहेगा शायद, ऑलरेडी फॉर्मूला लिस्ट में है. It is 1 minus lambda by mu. Okay. So it is total 1 minus how much time it is utilized. So जिसने बोला शायद इधर से देख के बोला रहेगा. Okay. Next. अच्छा, नहीं देखा था, ठीक है. Next is probability that there are n customers in the system. So as I told you, if you ask me sir आज चांस क्या रहेगा कि 11 बजे 10 ही लोग वहां पर रहेंगे. अगर मैं आज सपोज ब्रेक टाइम के पहले ही चले जाता हूँ, ब्रेक टाइम में तो बहुत गर्दी हो जाती है, सब लोग जाते हैं. ब्रेक टाइम से आधा घंटा पहले अगर जाऊंगा तो वहां कितने लोग रहने के चांसेस है, तो दैट कैन बी फाउंड आउट फ्रॉम हियर. सो Pn, अगर वहां पर 10 लोग रहने के चांसेस है, उसके चांसेस क्या है, 9 लोग होंगे उसके चांसेस क्या है, विच कैन फाइंड आउट इजीली फ्रॉम दिस फॉर्मूला. PO into lambda by mu raised to n. And what is PO? PO is this 1 minus lambda by mu. That is probably that it will be idle. So what observation we are making from here is, in any formula of queuing theory, the main things are lambda and mu. And after reading the question, if you extract lambda and mu wrong, the entire problem of 10 marks will go wrong. And also emphasize on the units. What is lambda? Lambda is arrival per hour, mu is service per hour. In simple terms, if I tell how many persons are coming per hour, and mu is how many persons are getting service in 1 hour. That is the simple meaning of lambda and mu.